numerical methods the sign change method, also known as roots in an interval. So let's start by looking at how we define an interval on a number line. So the value of x equals 4 is included, and the value of x equals 7 is included, and all values in between. So using inequalities we can state this. Using interval notation, where the square bracket means x equals 4 is included, and the square bracket here means x equals 7 is included. We can also use set notation. The values of x such that x is greater than or equal to 4 and x is less than or equal to 7. So any notation here can be used for this interval. In this example, x equals 4 is included in the interval, but x equals 7 is not. So inequalities, interval notation using a rounded bracket which represents x is less than 7, and then we have set notation. Here neither x equals 4 nor x equals 7 are included, so for inequalities, using rounded brackets for the interval, and then we have set notation. Okay, next example, x is greater than or equal to 6, and the 6 is included, and this goes to infinity, so inequality form. Now this might be easier to understand if we write the inequality form like this. So you can see that the upper limit is infinity, but we've got a rounded bracket because it's x less than infinity. And then we have the set notation. And if we have two separate regions, then we have x is less than 4 or x is greater than or equal to 8. This is not and. Using interval notation, separate notation for each part. Using set notation, the values of x such that x is less than 4 or x is greater than or equal to 8. Okay, so that's enough of intervals. Let's have a look at an example. So I'm starting off with this equation. We want to solve this using a numerical method. We're not using algebraic methods here. So we have a function of x, 2x squared, is equal to another function of x, 1 over x minus 5. To use the sign change method, we must have a function of x that's equal to 0. So here's the original equation. We take everything to one side, so the whole thing is equal to 0, which means this represents f of x, like so. So we can say that y is equal to f of x. So if we were going to sketch this particular graph, y equals f of x, or we could say y equals 2x squared minus 1 over x plus 5. So let's assume the graph of y equals f of x is this, and we can see that we have a root. And let's say that root is in this interval between x equals a and x equals b. So my y-coordinate at this point, when x equals a, is given by substituting in x equals a into here and working out f of a, and it's negative. And my y-coordinate here, when x equals b, you put in x equals b in here, you work out f of b, and we can see that one's positive. There is a sign change. If you have a sign change in your y-coordinates, it means your curve has gone through the x-axis, which means there was a root present. That's the essence of the sign change method. You suspect to begin with that you have a root in a given interval. You work out the y-coordinate for one point, you work out y-coordinate for the other point, you check the signs. If the signs change for the y-coordinates, it means your curve went through the x-axis, so there's a root. So a quick summary of the example that we just looked at. And here we're just looking at the signs at A and B. This one was negative and this one was positive. So if you see a sign change, make sure you write down there is a sign change, therefore root or hence root. You should always state this. Here's another example where we have a positive y coordinate here, a negative one here, sign change, therefore root. In this example, both y coordinates are positive, so the curve doesn't go through the x-axis, no root. Here we've gone from a positive y coordinate to a negative one. There is a sign change, but clearly there is no root. There is an asymptote on the graph, so you need to be careful when you see an asymptote in a given interval. Then that interval should be avoided. To use the sign change method, your function must be continuous in the interval. This asymptote could lead you to assume that there is a root in the interval AB because there's a sign change, but clearly there's no root. In this example, the lower limit A is given. If the upper limit was here somewhere, that would be sensible. We can see there's one root in the interval A to B, a single root. However, if the interval's too wide, you might find you have multiple roots in the interval. So here we have 3 roots, and we have gone from a negative y coordinate to a positive one. There is a sign change, and we have an odd number of roots. So if you have multiple roots and there's a sign change, it means the number of roots is odd. Likewise, in this example, if I chose B to be here, there's one root, but if B is down here, so the interval's too wide, we now have 2 roots here and here, and the y coordinate here is negative. The y coordinate here for x equals b is also negative. So if you have multiple roots and the signs are the same, so they could be both negative or both positive, it means you have an even number of roots. So in this graph you can see that you have multiple roots, the signs are both positive, so they are the same, so we have an even number of roots like we did here. Okay, so a summary of the whole method. So we started off with some equation that we rearrange so that all of the terms are on one side and 0 is on the other side, so we can call this f of x equals 0. We select an interval, and that interval is either given in a question or it may come from a graph. You may have sketched graphs and the graph is indicating what the interval should be. You work out your value of f of a, so you take the lower limit for the interval, you substitute it into your function, and you check the sign. It could be positive or negative. Yeah, that's just an example. Could be either. You do the same with the upper limit for the interval. You substitute that into your function, and again you're looking for the sign. Is it positive or negative? So a sign change here would suggest there is at least one root in the interval. Now it could be that in the question it said that there is clearly one root, then you don't need to say at least one root. Or on a graph you've seen there's exactly one root in your interval, then again you don't use these words, at least one root, then you would just say sign change, so hence root in the interval.